In this lecture, we're going to be discussing the difference quotient. I'm just going to adjust my camera here. So what is the difference quotient? It's a formula. And for UTM, they give you the formula on the final, but you have to know how to manipulate it. So suppose we have a function f. So the name of this function is f. And suppose I choose 2 points on this function. So I know that the x-coordinate of this point is x. And because this function is called f, the y-coordinate is f of x, whatever that evaluated at this x point is. And then if I go over to the right, h units, then where is this going to be on the x-axis? Well, it's going to be x plus this h. So this point will have x-coordinate x plus h. And since the name of this function is f, the y-coordinate is f of whatever the x-coordinate is. So where does the difference quotient come in? Well, now if I draw a line that goes through these 2 points, now my line's pretty thick here, this orange line is called the secant line. And we can get the slope. So m is going to be the slope of the secant line. So the slope of the orange line, and the formula that we have for it is called the difference quotient. So to get that slope, we want the difference quotient. And so it's going to be f evaluated at x plus h minus f of x all over h. And of course here we have the stipulation that h is not equal to 0. So this is the difference quotient, this formula here. You will be given that formula on a test and on the final, but you have to be able to manipulate it and to evaluate it. So what do we mean by that? Okay, so example. Let's let f of x be 2x squared plus 3x minus 1. Okay. And find the difference quotient. Okay. So we'll be given the formula for the difference quotient. So we already know what this is. I've got the formula for it right here. So I already know what this is. So what we have to do now is find f evaluated at x plus h. So going back to where you've learned how to evaluate functions, if this is my formula for the function, what is f evaluated at x plus h? Well, if it's something more complicated than just x, what we do is we rewrite the formula where my finger is, and everywhere there's an x, I put in blank parentheses. Okay, and now what do we want? We have been asked to find, if I can get a better color, f of x, f evaluated at x plus h. So that's what's now going to go in here. But I have to write this without parentheses. So going on order of operations, which we've already learned, to be where we're at now, that has to be done first. The 2 cannot be multiplied inside there first. So the 2 is just going to stay out of the picture, and I have to square x plus h. X plus h all squared is not x squared plus h squared. It's x plus h times itself. Okay, now moving along to this term, to write that without parentheses, the 3 has to be distributed through. And then plus 3 times h. Inside here, I have to FOIL this. So I'm going to have x squared plus x times h plus h times x. So those can be combined into 2xh. The order doesn't matter in the product. And finally, plus h times h plus h squared. The last step here is to multiply the 2 through so I can get rid of these square brackets. So 2x squared plus 4xh plus 2h squared. Now, all of the parentheses, all of the grouping symbols are gone. I just have to see if there's anything that can be combined. I only have one x squared term. I only have one x times h term. I only have one h squared term. I only have one x term, and I only have one h by itself term. And no, okay, so that's as far as it can go. Okay, now I need to put these into here. So what is the difference quotient? The difference quotient is f of x plus h minus f of x all over h. So now I'm going to rewrite that. What is f of x plus h? I just found it here. So I'm going to write that in. Okay, so I'm done with that. Then I have minus f of x. That's minus the entire formula for f of x. And what was the formula for f of x? 2x squared plus 3x minus 1. Then all over h. Okay, now I've got to write this without any parentheses. So I'm just copying what's here before. Then I've got minus 2x squared minus 3x minus negative 1. Okay, so here's where I am. Now I see, does anything cancel? Yes, I do. I've got a 2x squared here, and I have a minus 2x squared there. They cancel. I have a plus 3x here, and I have a minus 3x there, and they cancel. So if you didn't apply the negative sign all the way through, you're not going to get that cancellation. Similarly, I have a minus 1 here and a plus 1 there. If you didn't apply the negative sign all the way through, you're not going to get the cancellation you need. So what is left after cancellation? Let's write the largest power of h first. So I'm just going to swap up the order. Then I've got a plus 3h. And that's it. And is there anything we can cancel? Well, does the numerator have anything in common with all of those terms? And they all have an h in common, so we can factor the h out. What is left when you factor out the h? Well, here we'll have 2h. If I factor out the h from this term, I'll have 4x. If I factor out the h from this, I'll have plus 3. Now I can cancel the h's. because I have a product in the numerator, h times all of this over h. So the h's here will cancel because we have a product. And after cancellation, I'm left with 2h plus 4x plus 3. And that is the answer. Okay. So after doing this one example, there is enough in here where you should be able to handle anything that comes across your way. It shouldn't be more than degree 2, your function. I mean, yes, we can do degree 3 and higher. That's going to take a lot, but the ones that you will get on the final won't be more than degree 2. So if you know how to handle a function that's degree 2, you should be just fine. So the first thing you have to do is to find f of x plus h. Once you find that, then you need that and your original one put into the equation. Most common mistake here is the student will not put the negative sign all the way through. They just apply it to the first term, and that's why everything comes undone and you're not able to cancel the h's at the end. Okay, so that finishes the lecture on the difference